Solving quadratics using the zero product property. In this video, you're going to learn how to find the solutions to quadratic equations. In doing so, we're going to use something called the zero product property. Before I continue with this, I want to pause for a moment and let you know that what's going to be included in this video is learning or remembering actually how to factor. In case you forgot, to factor we use the x and we set up the b value to be up here, the c value to be up here. B came from the coefficient of x and c is your constant. Now on the sides here we had the factors, numbers that multiply to give you c, and at the same time they combined to give you b. So I'm going to call these factors m and n. So after we found our factors, we set up our two binomials with the factors in there. Okay. So again, this is still the same process. The only thing now is that the zero product property allows us to set up this quadratic expression equal to 0. So if the quadratic expression is equal to 0, then our factored expression is also equal to 0. What we do next is we separate each individual binomial, we set it equal to 0, and we isolate the x, meaning we solve for x. So we would need to move this term over, and in this case it would be a minus, but remember it's not always going to be minus. And we move, and in the other binomial we would move the n over, and again it's not always going to be minus. We would get our answer. In the end we end up with two solutions. Now they won't always be two different solutions. Sometimes they're going to be two solutions that are the same, and it's going to be known as one solution. And sometimes, again, the factoring doesn't always work. So let's go ahead and try this example. We're going to factor and then we're going to solve. So the factoring process is setting up our x. Remember that the b value goes up here and the c value goes down here. B is our 7 and c is our negative 18. Okay, so we need to find the factors of 18 that can combine to give us a 7. The only two pairs that can combine to give us a 7 are the 2 and the 9. The 9 has to be positive and the 2 has to be negative. So next we set up our binomials. Now remember, because this expression is equal to 0, the binomials are going to be equal to 0. So here we have x minus 2, x plus 9, and again, set each individual binomial equal to 0. That way we can solve and find our solutions. So in this first one, we're going to move the 2 over by adding, and we get x is equal to 2. In this next one, we're going to move the 9 over by subtracting, and we get that x is equal to negative 9. Now, pay close attention to the solutions that we got. X is equal to 2 and x is equal to negative 9. These solutions are similar to the factors that we found, but they're not exactly the same. Please don't get this confused. Our factors were a negative 2 and a positive 9, but yet our solutions were positive 2 and negative 9. Okay, so let's try a different example. Find the solutions to the quadratic equations. In this problem, we have a leading coefficient of 2, so we got to stop and think, okay, 2, 5, and 3. Is there anything they have in common? Is there any GCF, something we can factor out before we start? The answer is no. So next we move on to our AC method, also known as the headphone method. So we multiply A times C, that's why it's called AC method, and we set up our X. So B, which is 5, goes up here, and the product of A and C go up here, or goes up here. Next we need to find the factors of B that will give us that 5. So 1 and 6, 2 and 3. Now you got to be careful because both 1 and 6 and 2 and 3 can somehow give us a combination of 5. But the one that we're looking for is the one that's going to be both positives. So 2 and 3. Next we set up our factored binomials. Since the expression is equal to 0, then the equation has to be equal to 0. Since we have a leading coefficient, that means our binomials need to have the same leading coefficient. One is going to have the positive 2, and the other is going to have the positive 3. Now let's not forget that if we were to multiply and go backwards, 2 times 2 is not 2, 2 times 3 is not 3. So one of these binomials can get even smaller, and in this case is the first binomial, and we get x plus 1. The second binomial, nothing changes, so both are still equal to 0. We set each individual binomial equal to 0, and we solve for x. So we move the 1 over, and we get that x is negative 1. We move the 3 over, and we get 2x is negative 3. Then we divide by 2. Now you want to keep your solution in fraction form unless you're specified to round. So this would be our one solution, and here we would have our different solution, and this would be a 2-solution equation. We got 2 solutions. Okay. Next one. So looking at this expression here, it's a quadratic, but remember quadratics look like this, usually a trinomial. But here we only have 2 terms. We have the x squared term, and we have the x term. What we don't have is that constant term. It's missing. Okay. So how do we factor? Looking at both terms, the GCF would be x. So they have an x in common. That means we can factor out an x. In other words, we can divide by x on both. So we get x minus 24 after we divide, and this is equal to 0. So what we do next is we set each individual equal to 0. So x is 0, and x minus 24 is 0. You would need to solve for x, but if you notice on this binomial, or in this monomial, there's nothing to move left or right. So it's already equal to 0. Guess what? One of your solutions is 0. This other binomial, we move the 24 over, and we get that x is 24, positive 24. And here's our second solution. So our solutions, sometimes you'll see it as brackets, are 0 and 24. Okay. Another one. 2x squared plus 9x is equal to negative 9. Now, if you've noticed something about the previous examples, they've all been equal to 0. Well, that's because the zero product property says they must always be equal to 0. In this equation, it's not. So what we gotta do is get it equal to 0. So this 9 doesn't belong there. we're going to move it over to the left side, and in doing so, we're going to add it. Now we're not going to add it to the 9x because 9x and 9 are not like terms. We're just going to add it behind the x term, and there you go. Now it's equal to 0. So we got a factor. 299, nothing in common. So what we do next is, again, headphones, AC method. So we set up our x here, and we have that positive 9, our b is going to go up here, and 2 times 9 is 18, so the product of a and c, which is 18, is going to go down here. So we need the factors of 18 that when we combine them, they're going to give us a 9. The only numbers that come close to giving us a 9 are 3 and 6, which both have to be positive. So we set up our binomials, and because the equation is equal to 0, the binomials have to be equal to 0. Since we have a leading coefficient of 2, both of these binomials have to have a leading coefficient of 2. So here we have a plus 3 and a plus 6. So again, if you stop and think for just a moment, 2 times 2 does not give you 2. It gives you 4. 3 times 6 does not give you 9. It gives you 18. So one of these binomials has to reduce, make it smaller, and it's going to be the second one here. So our first binomial remains the same. The second one reduces to x plus 3. Both of these are equal to 0. And then we just have to set each individual one, set it equal to 0. And again, solve for x. We move the 3 over. We get 2x is equal to negative 3. Divide by 2. And keep your answer in fraction form. So we found one solution. Move the 3 over, and so we found our second solution. Okay, next one. Again, quadratics must be equal to 0. If they're not, rearrange it so they are equal to 0. What we're going to do here is we're going to move the 12x term over to the left-hand side and the 5 term over to the left-hand side. To move the 12x over, we will have to subtract it. To move the 5 over, we will have to add it. So I know it looks a little confusing. What I'm going to do is rewrite it in standard form. So I'm going to start with the 4x squared, followed by the 12x, followed by the 5, and now this is equal to 0. Okay, perfect. Now we can factor. 4, 12, and 5. Anything in common? All 3 of them? No. So what we do next is headphones. 4 and 5. In multiplying 4 and 5, we get positive 20, so our 20 goes down here. So again, this is B, this is the product of A and C. And we got to find the factors of 20 that are going to give us 12. We start with the smallest, 1 and 20, 2 and 10, 4 and 5. So the only ones that can somehow give us a 12 are 2 and 10. Since 12 is negative, then they both have to be negative. So we set up our binomials. They're equal to 0. 4x must go in both of them. We have minus 2 and minus 10. Then we have, okay, well, 4 times 4 does not give us 4. So we got to reduce it a little more. This can be reduced by 2. And the second binomial, well, this can also be reduced by 2. Next, we set each individual binomial equal to 0. And then we solve for x. So we move the 1 over by adding. We get 2x is 1. Then we divide by 2. Keep your solution in fraction form. So x is 1/2 is our first solution. In our second solution, we got to move the 5 over by adding. So we get 2x is 5. Then we divide by 2. And we get that x is 5 over 2. And these are our two solutions. Okay, and now you've learned how to solve quadratic equations using the zero product property.